Welcome back to Database Internals Crashcasts. I'm Sheila, and I'm here with Victor to dive deeper into the fascinating world of databases. Before we begin, if you're enjoying our podcast, please take a moment to rate us on your favorite podcast platform. Your support means the world to us.
Thanks, Sheila. Today we're continuing our journey through the Introduction to Databases season, focusing on the data modeling chapter. Specifically, we'll be exploring entities, attributes, and relationships, the building blocks of data modeling.
Absolutely, Victor. And to kick things off, I've got a fun quiz question for our listeners. Picture a library management system. Can you identify 3 entities, 3 attributes for one of those entities, and 2 relationships between the entities? Take a moment to think about it, and we'll reveal the answer at the end of the episode.
That's a great question, Sheila. It really gets our listeners thinking about how to apply these concepts to a real-world scenario. I'm curious to see what they come up with. There are quite a few possibilities, aren't there?
Indeed there are, Victor. Now, before we dive in, could you give us a quick refresher on what data modeling is and why it's important?
Certainly. Data modeling is the process of creating a visual representation of either a whole information system or parts of it to communicate connections between data points and structures. It's crucial because it helps us organize data efficiently, avoid redundancy, and ensure data integrity in our database systems.
Thanks for that recap, Victor. Now let's start with the basics. What exactly are entities, attributes, and relationships in the context of data modeling?
Great question, Sheila. Let's break it down. 1. Entities are objects or concepts about which we want to store information. They're usually nouns, like a person, place, thing, or event. 2. Attributes are the properties or characteristics of those entities. They describe the entity in more detail. 3. Relationships are the connections or associations between different entities.
I see. So if I understand correctly, in a university database, student could be an entity, student ID, and name could be attributes of the student entity, and enrolls in could be a relationship between the student entity and a course entity. Is that right?
Exactly right, Sheila. That's a perfect example. Now let's dive a bit deeper into each of these concepts, starting with entities. Did you know that there are different types of entities?
Really? I didn't know that. Can you tell us more about these different types of entities?
Certainly. There are 3 main types of entities. 1. Strong entities. These can exist independently of other entities. In your university example, both student and course would likely be strong entities. 2. Weak entities. These depend on the existence of another entity. For instance, an exam entity might be weak if it can't exist without a corresponding course. 3. Associative entities or junction entities. These represent a many-to-many relationship between 2 other entities. For example, if a student can enroll in multiple courses and a course can have multiple students, we might have an enrollment associative entity.
That's fascinating, Victor. I can see how understanding these different types of entities could help in designing a more accurate and efficient database. Now, what about attributes? Are there different types of those as well?
Absolutely, Sheila. Attributes also come in several flavors. 1. Simple attributes. These are atomic values that can't be divided further, like a student's age. 2. Composite attributes. These can be divided into smaller subparts. For example, a full name attribute might be composed of first name, middle name, and last name. 3. Multi-valued attributes. These can have more than one value for a single entity. For instance, a student might have multiple phone numbers. 4. Derived attributes. These can be calculated from other attributes. An example might be a student's age, which could be derived from their date of birth.
Wow, I hadn't realized there was so much nuance to attributes. This reminds me of how in object-oriented programming, we have different types of properties for classes. Is that a fair comparison?
That's an excellent observation, Sheila. Yes, there are definitely parallels between data modeling concepts and object-oriented programming. In both cases, we're trying to represent real-world concepts in a structured, logical way. The main difference is that in data modeling, we're focused on how to store and retrieve this information efficiently in a database.
That makes sense. Now we've covered entities and attributes. What about relationships? How do we represent the connections between entities?
Great question. Relationships in data modeling are typically categorized based on their cardinality, which describes how many instances of one entity relate to instances of another entity. The three main types are 1, 1-to-1, 1.1. Each instance of one entity is related to at most one instance of the other entity. For example, in some countries, one person can have only one passport number. 2, 1-to-many, 1-to-n. An instance of one entity can be related to many instances of another entity. For example, one department can have many employees. 3, many-to-many, mn. Many instances of one entity can be related to many instances of another entity. For example, students can enroll in multiple courses, and courses can have multiple students.
I see. And I imagine these relationships can get quite complex in real-world scenarios. Are there any common pitfalls or challenges when it comes to identifying and modeling these relationships?
Absolutely, Sheila. One common challenge is correctly identifying the cardinality of relationships. It's easy to oversimplify and miss important nuances. Another pitfall is not considering the direction of relationships. For example, while a student can enroll in many courses, it's also true that a course can have many students. Missing this bidirectional nature can lead to incomplete models. Also, it's crucial to consider the participation constraints of entities in relationships. This refers to whether all instances of an entity must participate in a relationship, total participation, or if some can exist without participating, partial participation.
That's really insightful, Victor. It sounds like there's a lot to consider when modeling data. Do you have any tips or best practices for our listeners who might be new to this?
Certainly. Here are a few key tips. 1. Always start by clearly defining the purpose and scope of your database. This will help you identify the relevant entities and relationships. 2. Use real-world examples and scenarios to validate your model. If you can't represent a real situation with your model, it might need refinement. 3. Don't try to capture every possible attribute or relationship at first. Start with the most important ones and refine your model iteratively. 4. Be consistent in your naming conventions for entities, attributes, and relationships. 5. Document your design decisions and the reasoning behind them. This will be invaluable when you need to revisit or modify your model later.
Those are great tips, Victor. Now, before we wrap up, let's get back to our quiz question. Can you remind our listeners what it was?
Of course, we asked our listeners to identify 3 entities, 3 attributes for one of those entities, and 2 relationships between the entities in a library management system.
Right. And what might be a good answer to this question?
A possible answer could be entities, book, member and librarian attributes. For book, ISBN, International Standard Book Number, title and author relationships. 1. Member borrows book, a many-to-many relationship, as a member can borrow multiple books, and a book can be borrowed by different members over time. 2. Librarian manages book, a one-to-many relationship, as a librarian can manage multiple books. Of course, there could be many other valid answers depending on how you envision the library system.
That's a great example, Victor. It really helps to see how these concepts apply in a real-world scenario. To wrap up, what would you say are the key takeaways from today's discussion?
The main points to remember are: 1. Entities represent objects or concepts in our database. 2. Attributes describe the properties of entities. 3. Relationships show how entities are connected to each other. 4. There are different types of each of these elements, allowing us to model complex real-world scenarios accurately. 5. Careful consideration of cardinality and participation constraints is crucial for creating effective data models.
Thank you, Victor, for this enlightening discussion. And thank you, listeners, for tuning in to another episode of Database Internals Crashcasts. If you found this helpful, please visit crashcasts.com, join our Discord community, or support us on Patreon. Don't forget to subscribe and rate our podcast. Your support keeps us going. Until next time, keep exploring the fascinating world of databases.